Holmes are like the same person.
Sorry, I just started crying. Okay, yeah. Keep going.
And like I was like, they're the exact same person, you know, put like together this really big timeline and everything. And everybody's like, no, Cheyenne, you're crazy. Like they can't be the same person. And then, you know, my mom sent me like a thing and she was like, oh, you should watch the show. And it was like American Ripper. And she's like, this man who's a descendant of H.H. Holmes. Well, H.H. Holmes is just an alias name. It's not really his real name. But he was like, him and an old CIA agent are trying to connect the dots of H.H. Holmes and Jack the Ripper being the same person. So I've been like watching it and it's super fucking cool. I like got so excited when he like first made the statement, like, as a descendant of H.H. Holmes, I believe that H.H. Holmes and Jack the Ripper are the same person. I was like, see, I was like, I fucking knew it. I was like so excited.
That's always the best.
Yeah, I like texted my mom. I said, I will accept your apologies now because I'm not the crazy one anymore. Because they were like a lot of the evidence that goes into it. People are like, well, H.H. Holmes was born in America. Yes, he was. He was, you know, he was born in America. However, there's a time where H.H. Holmes is like undocumented, like he's not in the U.S. anymore. And then the killings start happening.
Yeah.
And, you know, with Jack the Ripper, and, you know, the killings were different, but they were the same. You know, serial killers have to change up their method to understand, like, what they want to do. And, you know, and then H.H. Holmes, like, alias name first started off as a pharmaceutical, like, doctor name. But, you know, his name ended up being on a list on, like, going back to America as soon as Jack the Ripper is like done. And that's like on the internet. Like I found that. And they did the exact same thing except in person. Like they went to London and found all these like actual documents like proving that. And I was like, I will accept your apology now. Cause I like listen, I looked over at my friend. I said, I solved this case before they even got the chance.
That's so funny.
No, I think it's really interesting.
That is really interesting. Okay. Y'all want to start so we can get going with our days? Okay. I need to catch up on the videos because I have not had time.
The last video is 27 minutes long.
Oh, shoot, I'm gonna need a.
And it takes forever.
Is it just like equations?
It's like synthesis, but you get the end product and nothing else, no starting, and you have a set of rules and you have to break it down as to how you made that.
Through the synthesis?
Yeah, through synthesis.
Oh, dang.
It's confusing and I don't fully understand.
It does seem very confusing.
That's what's up.
Okay. Oops. Okay. That's not the homework. Okay, hold on. I need to. Oh, shit.
That one's in the book. It's on page 530.
That's so unfortunate. My book just came out of its hinges. 530? Which one?
It should be down at the bottom.
Oh, that's just going to turn it into a CL, right? So it'd be D?
Yeah. Mm-hmm.
Okay, D. That makes sense. I'm guessing that's just like something that we have to memorize. I wonder if that would happen. Does it have to be like in the middle of the chain or can it like be in other areas?
It can be on the end as well. Like if there's an OH on the end, it would replace it with the CL, but it wouldn't be like a chirality center. It'd just be like regular CL. I'm sorry for Pixie. He's like really angry right now for some reason.
Right. So the next one is the next one in the book as well.
The next one are kind of in the book. So PCC is not, but the last one is. The why.
What do you mean? Oh yeah, why? Okay. So I wonder what PCC does. Isn't the Friedel-Crofts, or it's like gonna reduce it?
Yeah.
So it'd be E.
No. You
What?
shouldn't be losing carbons.
I thought it reduces it though to like this, like bond
Wait, which one are you talking about?
2 or Y. I thought it goes like
Yeah.
double bond O and then OH.
Yeah, it cuts off the carbons and goes to the benzylic position. So it's E.
Morgan, what did you think it was
I thought it was D,
and why?
just because of the carbons. But I forgot that it just ends it.
Yeah, I'm pretty sure that was the reaction that we had like last time, and it like just
Yeah.
cuts off all of the carbons.
It puts it on the benzylic.
Yeah, it's called Clemenson or whatever.
Also, PCC is also in the book. It's
What
on
page?
page 534. It just has something else with it. It has like CH2Cl2, but PCC isn't the book.
Oh yeah, it's with CH2 CH. So just turn it into a.
ketone.
But would that cut off all of the carbons too?
No,
I
it
don't
doesn't.
think so.
So it just turns it.
It'll be a terminal ketone, so I'm pretty sure it's A.
Would it have an H group though, or an OH group?
No,
Well,
right?
Or would it turn
What?
it to C? Because it would be an R and then an R group.
well,
bottom?
see, you're adding an additional carbon.
So wait, PCC doesn't make an aldehyde?
It adds the double bonded O and a hydrogen. Like
Yeah,
you're not gonna
aldehyde.
add it. Yeah, you're not gonna add the additional carbon on it.
So which one?
It just says under these conditions, the alcohol is oxidized to give an aldehyde,
So
which
it's
is
H,
not further oxidized.
or it's either A or H.
So it's the alcohol is oxidized to give a ketone. So it'd be A.
That's what I'm thinking.
That's what I have as mine.
Shine, do you have something else?
Mm-mm.
You have A? Okay, sounds good. Okay.
Question the small reading section of the chapter.
Is it the very first one?
539, page 539. It has like the little beanie thing on it.
Yeah, okay, hold on, let me read this. Is it formaldehyde?
No, if you that's formed with methanol, this one's asking about ethanol.
Oh, that makes
It's at the very end.
Acetyl aldehyde.
it produces acetaldehyde.
Mhm.
There we go. I didn't read.
Yeah, I didn't either.
I am this weekend though. Tomorrow. I just have not had time. Okay. So this one, I'm guessing you're gonna want to add you're gonna want to take the alkene and add a product on it, like a BR group or CL group. I'm guessing that's the first step.
You're gonna the
So-
first step is you're gonna want to turn alkene into a OH.
Yeah,
Okay,
because none of the
OH.
because none of the products that are down here is going to give us like the proper leading group. So the OH is going to be your best bet.
So you just add the OH and then add the rest of the chain.
No, because the OH would stop it from doing the Gringard's reaction.
Okay.
So you have to change the OH into a ketone.
So it goes alkene, then OH, then ketone, then add the chain, then reduce.
There
to an
should
OH.
only be
The one thing I'm confused about is
Uh,
that it changes the carbon amounts.
no. So yeah. I mean, you add the chain and reduce it, and that's all in one step. Like it'll be one letter.
Okay, hold
So
on.
we've learned
Do you-
3 different ways to add carbons. There's the fetal crafts.
Mhm.
There's the term like the 3, the alkynes
It's
thing, and then the
This
terminal
one.
alkyne, and then there's the Grignard's
Yeah.
reaction.
So do you remember how Grignard's it can add chains to it?
yeah.
That's what we're gonna use.
All right, so we're gonna. So how do you make it an OH group first?
Well, if you look at all your options, there is H can give you an OH group, because I don't want to tell you the answer. I kind of
Is it
want
J?
well, no. But there H can give you an OH, B can give you an OH, J can give you an OH, M can give you an OH. And there's probably like a couple more in there, but oh, I can also give you an OH.
I don't think H could give you an OH.
It doesn't. I don't know. I read that as H2O.
I was gonna say I think that gives you a double bonded O.
The first thing I want to think about is which ones that give you an OH and where they're gonna add it.
No, I'm trying to think. Okay, one. According to our notes,
Morgan, have you submitted it, by the way?
No,
Okay, well, I'm gonna tell you that you were correct.
on the mechanism.
okay, so I'm
Mhm.
guessing what you're gonna do is you're gonna start at start at B, because that's gonna give you it at the end,
Mhm.
because it's going to go to the least substituted side.
Now, what did we learn about this past week that'll change it? It's not going to be one of our older mechanisms that'll switch it to an ketone.
Is it this one?
But
Is
it's
it
something we
C?
just learned.
Is it C?
No.
Well, but those will give you an OH at the end.
Your first step is correct. It's B.
Yeah. B is
I
correct.
thought you meant
but
that it
you're-
was incorrect. That's
She
what I
was
was
trying to talk about the second step.
Oh, okay. I was so confused. So you're
yeah,
talking
I
about-
said B. I said B is correct, and your second one's going to be something that we learned this week,
so
or
you're
in
gonna-
chapter 12.
It's gonna be the Grignard reaction.
No, that's going to be your last step.
It's something that we
Because
just
you-
learned.
What are you doing after you add the OH?
So after you add the
Protonating.
OH, you're going to want to switch it to a ketone, because with Grignards, you can't do it with an OH on it.
So you want to deprotonate?
Yes. You want
You
to
don't
make it
want
from
a
an OH to a
ketone,
ketone
You want an aldehyde.
or aldehyde, yeah.
Just
Whatever.
the-
I'm
the
mixing up
carbonyl.
all of them.
You want the carbonyl.
Double bonded oxygen, if you will.
Yeah.
Anthony, how do we do that?
That would be See, you
Hey,
tell me.
Pence, look at question 2.
I forget how to.
Bro, I was literally looking around in the notes and I'm like, what the fuck are they talking about?
Look at question 2. Oh man, what kind of ghost said that?
It just says Arios. Arios.
No, like, look at question 2 on the homework.
Oh my God, you guys got me.
I'm so sorry.
To use PCC.
Yeah.
PCC.
And then Gracie, you had the last step.
Okay, and then the last step, hold on, I need to find
Go Grignards.
G, and then the last step is going to be, oh my God, okay, so you already added a ketone, and then you're gonna need to reduce it.
So your only options for Grignards are U and Y
Yeah,
Y
so
has
you're
too
gonna
many
need him. I
carbons.
gotta find it. CH3.
Let her think. She's got this.
Oh my God, it's not even on here. Hold on. Oh, hold on. Beetle crafts.
No, you're thinking too hard.
This one, B.
No.
You already said it. You already know what you're doing.
Yeah.
You said,
You,
you said
know your
Grignard.
last
No, but I
one.
don't. The greener one.
All right. So the
CH3
Grignard
MG is not on
in
there.
Grin yeah.
Oh, it's hold on. I found it. Hold on. It's this one. Hold on. How many carbons? Hold on. I need to figure out how many cards are there. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So it's gonna be 2. So it's gonna be you.
And that's it.
Let's go.
Let's go.
Not needed. No, but it was really messing with my head that I just said CH3 MGBR because I kept on saying, where's the CH3? But then I didn't realize I was just like, it's fine. It's just one of those days.
This one's in the videos. Have you watched it? It'll be C.
Wait, explain.
Because, okay, so it says, what is the pin ultimate product? So I looked up what a pin ultimate product is, and it's the closest to the ending product. And A is the starting product, and C is the product right before you get to your final product, like in the synthesis pathway.
Okay.
I don't remember what video that was in, but I had to search for a while.
I'm gonna have to watch those anyway. Well, what do we talk about for 15 minutes?
I don't know. I'm just gonna spin it. What happened?
Sunshine and rainbows.
Okay. We can do the
Oh, I've been putting together a list of like all the mechanism things from like chapter 7 to the one we're on. And once I'm done, I can totally send that to you guys.
yeah, that'd be amazing.
It's not the first time. I've
It's
been-
just so I don't have to scroll between every single chapter.
Do you guys want to like work on the oops, I keep on do you guys want to work on the
Oh, shoot.
homework or slash in-class practice for 15 minutes? And we can just get ahead of the game.
Or which one?
Like 15, 16, 17.
Shut your eyes.
How did it count off points for me?
Which one? We have to do this meeting.
On 4, I got 1.25 out of 1.5.
For which one?
Not put
Four?
the not needed in.
I have not needed in step 4, 5, and 6.
Hmm.
Oh, I spelled not needed wrong.
Oh no.
I'm
I
sure
have
Just
3
ask him.
E's.
Are you ready?
Jessica
Yeah.
will probably give you that point back.
Yeah. I
You
put
silly
3
goose.
That's so funny.
E's. I was like, I have everything right. I don't know what's happening.
Gracie, for the end, are you talking about like the class notes?
Yeah.
Okay. I was like, huh?
Sorry, I was not very clear with that. Yeah, we can just go on to 15.
It's gonna suck the more you wait.
Yeah, I agree.
It's gonna stop. Like it's gonna hurt your mental. Going, but like if you don't have all your thoughts together.
Wait, draw the mechanism in the parts of this reaction. Wait, the one thing I'm confused about is that in the book on page 531, it explains that PBr3 like changes the like formation of it. So that's how I was confused. Like,
Well,
like
that- Oh. It kind of reminds me of like that triangle bonding thing that we learned last semester.
oh, with the O3 something.
Yeah, but this time it's like adding to itself.
Mhm.
So it flips the chirality and then it adds a BR.
It doesn't even add a BR, it just connects it. It has like a dibromide and then like plus the quote unquote ring with the R group.
Wait, hold on. I feel like I did this in SI. Yeah. Okay.
Do you have it?
Yeah.
Do you want to share or do you want me to share your screen or something?
Yeah. I'll have to join on my iPad real quick. I got
Wait,
this.
it doesn't add a BR?
It does.
It does?
Yes.
Hmm.
There's some
I
pages
can show you the
on
mechanism.
Oh wait, this is a question. Never mind. I don't know why I read that as a mechanism itself.
See, can you let me
that.
in?
Sorry, Morgan.
You're fine.
So OH is a bad leaving group, so it forms a complex with the PBr3.
Oh,
What
it's-
is-
We did something like that, didn't we?
I think you have to make me a co-host.
Oh, hold on. Sorry. More.
You're all good.
How do I make?
Or maybe it's because you're sharing.
Oh yeah. Stop sharing.
Nope, it won't let me in. Yeah, I need to be like a co-host or something.
Host. Change host. We're gonna add as a host now. Is it
Awesome.
working?
Thank you.
I don't think your thing is showing up.
There we go.
That's not what I wanted.
Oh, that's genetics.
At least very colorful.
Thanks.
Oh, I hate
Sweet.
genetics.
How'd that
Genetics
test go?
did me dirty today.
All right. Gracie, what did the question look like again?
It was like
It was
one,
like this,
2,
right?
3, 4, 5. So 1, 2, 3, 4, 5, and then an OH on the second carbon.
Oh,
Yeah. Or on that's no, that's a methyl group. Yeah, and then yeah. Or hold on. Actually, that is wrong. It would
Actually-
be like
What's the difference?
just put the OH on the left of the meth. Hold on.
You
here.
just have one additional carbon
You
on
have too
there.
many bonds. You have too many carbons.
No.
So just and then put the OH now on the where you put it originally. Yeah, there you go. There you go.
Okay, I don't know why this is so messy. I apologize. All right, so it's gonna be BR, P, BR. Let's not look at that.
It's non-BR. I think it'd be
BR.
3 BRs on it. Yeah, I was gonna say.
Yeah. And so your OH has two things here.
Especially
And it does attack the, oh no, it attacks, okay, hold on, I got it. It's gonna attack the P, it's gonna knock this off. So then you have O, H, P, BR2.
Oh, isn't this the thing that we just like talked about where it like comes on and then it goes off somehow?
Yeah. And then, now this is a good leave-in group. So you're gonna wanna, because that causes this bromine to have a negative charge. So that comes back here. And it comes in from behind and attacks here.
So this is like an E2
this-
reaction.
Yeah, this leaves.
SN2.
And so
Organic.
Ken,
Mhm.
then it should be this.
Why would it be behind? Is it taxed from behind?
It's SN2, remember? The backside attack.
Yeah, it'll attack here.
Alright, that makes sense. Alright, so it's BR. Sweet.
And since this was on a wedge, it'll just switch to dash.
It doesn't mess with the chirality of the other one.
No, because
I-
it doesn't
yeah.
affect that one.
Okay.
Yeah. Since it's not attacking, that'll stay on a wet dash.
Cool.
Yeah, let's move on to number 16. Dang, we can flex in front of them. I've finished the packet before.
Sorry.
We get to class and it's like, all right, we're gonna move on.
Was there anything else from
We
these?
got it. We just sit there and talk the entire time. Okay,
Like
Do
the
we want
right
to work
side
on
of the
like this
rocket.
one?
Oh, I think this one's in the book, I'm pretty sure.
Yeah, the SOCL2, he's like, if you worked ahead, then you'll be able to do these. And it's like, I don't care.
Well,
if
this
you work ahead.
OH is gonna just get replaced with the CL.
SOCL does something.
Oh, it's just a CL.
Okay.
Oh, yeah. So just be. And then it's behind the thing, right?
SOCL does that. But I don't know how.
Well, it just says predict the products. You don't have to draw a mechanism.
So you just have to draw CL. Okay.
It
One.
literally just replaces an OH.
Yeah, but
All right.
it like changes to behind the plane. So that's what I'm confused about is how do you draw that? Because the method.
Well,
group-
this one, it might just, there's no chirality center on the first one. Like the CL is like when it just go on the end of it, like it wouldn't have to change the chirality or anything.
Yeah,
Yeah,
it
wouldn't it
doesn't
just look
mess
like
with
that?
that chirality.
Right.
This one would
The one I was
change
looking
to
for
a
in the book.
dashed.
Yeah.
Well, this one is which OH is it going to change though?
What do you mean which OH?
Because it's not excess.
I think it would be the
would
one
do the least substituted.
you do the one that has the most amount or the best leading group. The one attached to the benzene ring is not going to be the best leading group, wouldn't it not?
Yeah, this is a SN. Is this an SN2 or 1? Because this one's more sterically hindered, so I don't think it's going to attack here.
Okay, that makes sense.
Unless it attacks at both positions. But I guess that would be
Yeah, but I think I think you need excess for that. But then again, he said something about us not needing excess on something.
So the SOCL2 is a Grignard, right? It's a Grignard reaction.
I'm gonna like
What are you talking
Grignard is
about?
just MGBR.
more
It says
conversation.
in like the review of reactions that it's a
Oh,
It just
is
feels
it a
like
green?
Or
the
your free left.
OH is a
Green
good
reagent.
loop, which means that it's treated with the chlorine, and then the chlorine would take its place. So it's like an SN2 reaction.
So SN2. Okay.
Mhm. Right, so
Hey, we've hit 30 minutes.
what?
Almost. I said
We're calling it
we've
quits
almost
now.
hit 30 minutes. Now, did you start recording at exactly 15 or no?
Yeah, I did. So just wait
Are we
like
good? Like 2 minutes.
Yeah, we'll wait a minute.
let's do one more problem. We can do one more problem.
One
and then
more?
call it quits. Okay.
Where's my 12 in class? There it is.
So
What do you want to do? Give me a number, any number.
how long?
Let's
Oh,
do
23. Oh, that's a synthesis problem. That's me long.
Yeah, let's do 23.
let's do 21. Oh,
Is there a multiple choice one we can do?
yeah, 21.
Oh, yeah. Choose the reaction.
NGBR.
So we know that the first one's fetal craft. And the second one's a granule.
This wouldn't work. You'd have to have like that.
Wait, technically it's not.
Add, wouldn't you? No.
It's not A because that could apply to any position on the ring.
It would,
It's
would
a
rearrange.
orthopara.
It's C.
It would go there because this is an orthopara.
no, it would rearrange. It wouldn't give you that product.
Would it go here?
No, it would.
Oh yeah, you're right.
Yeah.
It would be like something wonky as shit.
I mean, wouldn't it not matter in this particular question?
Well, it wouldn't give you that product, which is kind of the point.
Because you remember how the thing it goes like AL and then it's attached to CL3s and then they change it like becomes a positive or it's a positive or a negative and then it moves the arrangement of the CL chain.
This rearranges, and that's why he wants us to do this with this chain, kind of like with the. If you wanted this, you would do like a CL.
Yeah.
And then like the ZNHG to
Yeah.
reduce it to that,
Start off.
because that would do I don't know, something up here. Wonky shit. So it's not A.
They all drop.
I feel like for B, you would need a group there first, like on the ring.
Yeah.
Like you would need something there to, like the SI thing, like the SI with like the little stuff with it, and then like the N, all that good stuff.
The one thing
I'm pretty sure you would. What's up?
I
What were you
was
saying?
with C, I just don't understand how that would add a MGBR.
So MGBR is already on it.
Oh,
So this is gonna attach this chain, and with this, it's gonna deprotonate it to OH,
Mm-hmm.
and then
you're gonna reduce that.
then
with-
you're gonna reduce this, and you're gonna leave it with the chain.
so I'm guessing C is the
So
best. You have one.
I'm pretty sure C's the best because it's just one outcome.
Mhm.
Whereas this,
Yeah,
I
what
don't
happens with
exactly
E?
know how
Can you
this would
try that
add. I don't know how that adds.
Hmm.
Because I haven't seen anything with Grignards that's BR. Because typically you need like a double bonded O on it, and then you would reduce that to OH, and
That
then
would
you
just
would
be the same
remove.
thing as the first one, really, wouldn't it? It just wouldn't.
Yeah.
Yes.
I don't even know if that adds.
Yeah. So C. Cool.
Pretty sure it's C.
I'm guessing that's the best choice.
All right. Well, that sounds good.
Cool.
Actually, it wasn't too bad.
All right, dogs. See you tomorrow morning.
All right.
9 a.m.
See ya.
sharp.
Bye, guys.
Bye guys. See you
Bye.
tomorrow.
See you later.